All right, Algebra 1, Lesson 54. We're going to talk about how to display data in a box and whisker plot. How many of you are familiar with box and whisker plots at all? 1, 2, 3, 4, kind of ish, 4 and 5. Okay, so you guys have seen this stuff before. Okay, great. We'll do a little bit of reading here. Box and whisker plot is just a different way to displays data, and it divides it into 4 groups. All right, those groups are known as the minimum. The minimum is going to be the smallest number in a set of data. Then we're going to have our Q1, and then we're going to have our median. We already know how to find a median, though, right? How do we find a median number? You put the data in a line, least to greatest according to value, and then find the middle number that's there. What if there's 2 numbers in the middle? Take the average. So I add them up, I divide by 2, sorry. All right, then I have Q3, and then I have my maximum. What is the maximum? It's the largest number in the data, right? All right, so the line inside the box shows the median. The ends of the box show the quartiles, and the ends of the whisker show the minimum and maximum values. So we have an example here. If we have 15 hockey games, we're looking at the number of goals scored in each game. Now, some of this is kind of crazy, right? Because what are the typical, how many goals are typically scored in a hockey game? What's that? 1 or 2, right? A lot of games are decided like one team scores 1 goal, and the other team scores no goal. You know, it might be at most, even if you added up the goals of both teams, you might get 5 at max. So this data is made up. Are we probably ever going to see a game where 9 goals are scored combined? Probably not, right? But it's possible, I guess. It's kind of like soccer. I mean, how many goals are typically scored in a regular soccer game? Anybody watch soccer? 2 or 3 max, right? And is that one team or is that both teams combined? One team. So you might see how many goals. What's the most number of goals you've seen scored in a game? Like not just one team, but both teams. You've seen 17 goals scored in a game? Oh, okay, so like Little League type thing. What about at like FIFA type, like professional soccer? 11. But that's probably not even typical, right? That's probably an outlier. All right, so we have goals of 1, 1, 1, 3, and these are ordered from least to greatest. 1, 1, 1, 3, 4, 4, 4, 5, 6, 7, 7, 8, 8, 9, 9. Our goals are scored. The number of goals scored can be displayed in a box and whisker plot, and it would probably look like this, right? We see our minimum is our 1, a median. We've taken everything up. We found 5 to be the middle number. We got our third quartile, and of course 9 is our maximum. Okay, does this all make sense so far? Okay, half the games had between 3 to 8 goals per game. 1/4 of the games had between 1/3, 1 and 3 goals scored. That's how we're getting those quartiles. Okay, the median number of goals was 5. The greatest number of goals on one game was 9. Okay. Okay, so what you're looking for is half the games had between 3 and 8. So that's what you're reading here. Is that box is where is half the data? Okay, half the data is between 3 and 8. Okay. Okay. A fourth, okay, so we're taking this half and dividing it in half, okay? And that's how we're getting that 3, okay? The median number and the greatest, all right, 1/4, okay? We're getting some of those numbers. Okay, in the quartile range, IQR is the difference between the third quartile, Q3, and the first quartile, which was Q1. Outliers are any values of x such that we see an outlier is going to be less than quartile 1 minus 1.5 of our interquartile range, or IQR. Okay, or our Q is greater than Q3 plus 1.5 IQR. In a box and whisker plot, outliers are represented by an asterisk and are not included in the whisker. Okay, so we won't necessarily include outliers. Okay. Okay, questions up to this point? No, we've got it so far? Nothing unfamiliar? All right. Let us see some questions. All right, so we have some data here for question number 1. We have 5, 4, 16, 21, 10, 6, and 15. Okay? What do I want to do with that data there to begin to help me out? Put them in order from, okay, what's the smallest number? So 4, 5, 6, 10, 15, 16. Anything else? 21. Okay, is that it? Let's go ahead and count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we've got all our data here, right? What things are easiest to make note of? My minimum and my maximum. What's my minimum? 4. Okay, so minimum is here. Okay, what's my maximum? 21. Okay, what's the next thing that's kind of easiest to find? The middle, the median. All right, so this is kind of how I do it, right? I've got, here is my outside, then I'm coming in, and right there. So what's my median? 10. Okay? All right. So we should have 4, 10, and 21 are my easiest things to find, right? And do I see any that don't have 4, 10, or 21 marked already? I can see at least one. D. D doesn't have what? Doesn't have 10. Okay? So what's next left to find? My inner quartile, right? How do I find that? Do we know? How do I find quartile 1 or quartile 3? Right? Because those are the things that are very different, correct? All right, here we see 6. Over here it looks like for Q1, looks like possibly 5, 5, 5, down through the rest of it, right? So how do I find Q1? How do I find Q3? Any thoughts? Let's see, not necessarily. All right. Let's take a second. Let's look at example. Oh goodness. All right, look at example 2. Okay, example 2 in your book. Okay, or at least, or we could even look at example 1. All right, talking about finding some of these things. Example number 1 in your book on page 346, it says the box and whisker plot shows scores on a history test. Use the interquartile range to identify outliers. Well, we don't necessarily want to do that. Not necessarily yet anyway. So let's look at example 2. Make a box and whisker plot to display the data of fish lengths in millimeters reported by the California Department of Fish and Game. Lists everything. Half the fish are between which lengths? Okay, so what we're looking for, and if you'll notice down below it, is that they've got from their minimum, but they exclude the median in terms of the half, right? So my interquartile range is going to be 4 through 6 and 15 through 21. If I look at the example in my book as an example of what to do with my data, does that make sense? Right? So this to me is one of those great things that as a student I want to be able to get down. As a teacher I try to get down because I try to continue to be a student, and my textbook is a great resource. Okay, so let's look and see what they do with it after that, because they show there 210, 213, 245, 298, 301, 312, and 323 as part of Q1. All right, so what then is Q1? Well, if you'll notice, 1, 2, 3, 4, 5, 6, 7, that 298 is Q1. That's what they're pointing to. All right. Do you notice that 298 is the median of half the data? Okay. Well, what is the median of my first half of my data? 5. Okay. What is the median of my second half of my data? 16. All right. So I should be looking where I have 5 and 16 and 21 and 4 and 10. Okay? Is B unique between, is it different than A and C? Yeah? Okay? Should be. Looks like everything's right with B, correct? Okay? Let's scroll down and let's see if our answer for number 1 is correct. Okay? We got B, right? Let's make sure that we got B. I think we got B. Anyway, okay. Do we understand how to find Q1 and Q3 now? Hopefully. All right. Was it as hard as it seemed? All right, good. Okay. Do we want to try another one of these? Just kind of make sure that we've got it down. All right, this one gives me the box and whisker plot, tells me to list a set of data values that can be represented by the box and whisker plot. What do we know about, let's look at this. We should be able to identify some things. What's the smallest number I should find in my data based upon the box and whisker plot? I should find a set of data where 4 is the smallest number. Now, fortunately for us, they've already got these ordered. So all of these have a minimum of 4. Is that correct? What's the maximum according to my box and whisker plot? All right, let's look through all the data. Do all of them have a maximum of 16? Yes. What is the median number? What is the median? What is the median of the set of data, of the whole data? 9. Okay, so now we're looking for one where maybe the median isn't 9, right? All right, so let's look through at our first one. How many numbers are in here? We got 1, 2, 3, 4. Here, I'll kind of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So I got 4 and 4, 15 and 5, 14 and 6, 13 and 7. Let's see, I said 13 and 7, 11 and 8, and 9 was the median. So could it be A? It could, it may not be, but so far that works. Let's look at the next one. It goes 4, 16, 6, 15, and then it shares 8 and 11. Well, what's 8 plus 11? 19. 19 divided by 2, is that 9? No, so B is out, correct? All right, let's come over here. We got 4 and 16, 5 and 15, 6 and 11, and then 9. So could C still work? Yeah, could still work. Here we have 4 and 16, 6 and 15, 7 and 8. What's 7 plus 8? 18. What's 18 divided by 2? 18 divided by 2? 9. So could that still work? Yeah, it could still work. Okay, so we haven't eliminated anything yet. All right, so let's look at our Q1. Our Q1 is 6, right? Okay, so let's look through here. We'll look through here. We already know that. look through this, look through here, look through here. And we want to find the medians of our halves, correct? In order to find our Q1. All right, so here I've got 4 and 8, 5 and 7. Is 6 the median? Yeah, so let's pick a different color here. So could this still work? Yeah, okay, let's come over here. Our quartile 3 is 15 over here though, right? Okay, so this goes 11 and 16, 13 and 15, and Q3 is 14. Does that match? No, so we can get rid of A, correct? Okay, that's handy. Let's look over here. We have 4, 6, and 5 as Q1. Is that match? No, so it looks like C is out, right? Okay, unless I'm wrong somehow. Might be wrong. And over here, looks like 15. Okay, that seems to work. Over here, okay, looks like, and I think probably what you're going to get is because that's 9 in there, that you could probably still include 4, 6, and 7, where 6 is your median. You could probably still include 11 with this, and so 15 is your Q3. So it looks to me like D is correct. Does anyone want to scroll down to the bottom and see if D is the right answer? And D is the right answer, correct? Okay. So this was wrong, okay, because it had 5. Do we understand how to find Q1 and Q3 now? Okay? So we could, not only that, but we can look at a box and whisker plot now and determine from different sets of values that are listed there which one is the right set of data. Okay? Are we feeling a little bit more comfortable with this? Okay, great. All right, let's clear out some of this. Let's probably try to do at least another one. It says box and whisker plots show the distribution of 2 data sets. Which data set has a greater median? This one should be really easy to see. All right, which one has the greater median? 1 or 2? 2, right? What's the median in data 2? 10. What was the data, or what was the median in data 1? 8. Okay, so you got B there. Okay, perfect. That was really easy. Okay, go ahead. Okay, so we want to find outliers. Let's see. I want to see if we have a question because I'd like to. Okay, so let's look at question 5. Okay, which data value is an outlier? All right. Let's see. Let's try to find one. All right. So example 1 in your book. Right? Because if you look at what it's asking, is it shows you a box and whisker plot, right? And the question that it asks, it says a box and whisker plot shows scores on a history test. Use the interquartile range to identify outliers. Okay? So let's try to identify that. So our first quartile is 70. Do we see that? So quartile 1 is 70. What is the third quartile? 90. So we see quartile 3. So our interquartile range, how are we going to find that? Well, notice that we're going to take Q3 minus Q1. So we're going to take, in this case, what's our first quartile? And what's our third quartile? So we're going to take 27 minus 24, right? So we're going to take the example that we have in our book, and we're going to apply it to our question, right? So what's 27 minus 24? 3. Okay, coming back to the question in the book, they take 90 minus 70, they get 20. All right, now what did they do with that 20? They multiplied it by 1.5. Now if I come back to my notes, let's see where my notes at. Okay, notice that we always multiply by 1.5. So 1.5 is part of the process. We don't have to find 1.5. 1.5 is what we use, right? Okay, so let's come back over here. Okay, so we're going to take 3 and we're going to multiply it by 1.5, right? So what do we get? What's 3 times 1.5? Everybody got a calculator? 4.5? Is that right? Okay, so we get 4.5. Now, in the question in the book, they took 20 times 1.5 and they got 30. And what you want to see that they do with that is they take that first quartile, which was 70, and they subtract what they got. So they took 70 minus 30. So we're going to take 24, and we're going to subtract 4.5. Okay, what's 24 minus 4.5? Would that be what, 19.5? Okay, so we get 19.5. Whenever they took their 70 minus 30, they got 40. So we subtract first. Then they take Q3. What's our Q3? 27. And they add 4.5. Right? Well, what's 27 plus 4.5? What's that? 31.5. Okay? All right. Let's see. So what they're saying is that no values, we're looking for, are there any values that are less, in our question, are there any values that are less than 19.5 that we see over here? Is there anything that is less, here's 19, so that would be 19.5. Is there anything further left than 19.5 in my box and whisker plot? No. Okay, let's come to 31.5. Here's 31, there's 31.5. Is there anything greater than 31.5 on my box and whisker plot? Does it go to the right any further? Yeah, it goes out to 32, correct? So 32 should be the outlier. Does that make sense? Now, in theirs, there wasn't anything less than 40, okay, because it stopped at 55, and there wasn't anything greater than 120 because it stopped at 100, okay? So do you see how you can use the example in the book to figure out how to read your own box and, how to read that? And you can use, basically as a principle of going back, I don't understand something. I'm going to find an example in the book that asks pretty much the same question. I'm going to study how they solved it and what kind of principles were working there. And I'm going to apply my own numbers and my own question to that same thinking. Okay, so hopefully we see how to, not only how to solve this question, but strategies in terms of how to use our book and how to use the examples in the book if you're not already doing that. Somebody, let's scroll down to the bottom, check number 5, and see, is A the answer? Great. So does this make sense now? All right. Let's see. What I want you to do is I want you to look in your book, in the homework, and see if there's any questions in there that you want to have covered. If not, I'll let you guys get to work. I'll hit stop on the video. Going once. Going twice. 7. Okay, 7. All right, number 7 takes place on page 348. Let me pull up kind of a blank page here. Okay. Question number 7 in your book, this is a lesson 41 question, says the formula converts Fahrenheit to degrees Celsius. It says C equals 5/9 F minus 32. It says on a separate sheet of paper, make a table of the equivalent Celsius temperatures to -4, 32, 50, and 77 degrees Fahrenheit. All right. So what they want you to do is they want you to create, and you could do this vertically or horizontally, but let's say it looked like this, where we had Fahrenheit and Celsius, and they give me a set of degrees. They give me a bunch of Fahrenheit, or let's see, equivalent Celsius to these degrees Fahrenheit. So 1, 2, 3, 4, and they give me degrees I think in order, negative 4, 32, 50, 77. Negative 4, 32, 50, and 77, right? So they give you those degrees Fahrenheit, and they want to know what the equivalent degrees in Celsius are. So our Celsius equals 5/9. What was it? F minus 32? Is that right? F minus 32. So this is my formula, and I want to solve for C 4 times. So I'll just kind of help you out with the first one. C equals 5/9, and then I'm going to plug in the first one, which is negative 4 degrees Fahrenheit. So I'm substituting for F minus 32. Okay, now it's an order of operations question, right? What do I do first here? Blayton? Not minus negative 4, because that would mean addition. It's just negative 4 minus 32, right? What do I get with negative 4 minus 32? Negative 36. So I have 5/9 times negative 36. And if I need to look at it, I can look at it as negative 36 over 1. Right? So I have 5 times negative 36 times 9, or over 9 over 1. So I know, what's 9 times 1? 9, so I know I'm going to get this. I know I'm taking a positive times a negative, so I'm going to get a negative number. What's 5 times negative 36? What? No, 5 times negative 36. Negative 180. So I have negative 180 divided by 9. Should be what? Maybe negative 20? Negative 20. All right, so what we're saying then is that if it's negative 4 degrees Fahrenheit outside, then it's negative 20 degrees Celsius. Okay? So what you're going to do, because I think you can do this, right, is can I erase this? We have this work shown for negative 4. All right? Okay? And you're going to show your work, you're not going to erase it. But the next thing I'm going to do is what am I going to plug in for F now? 32. All right, this one actually should be pretty easy, right? Because what's 32 minus 32? 0. And what's 5/9 times 0? 0. So what is 32 degrees Fahrenheit in Celsius? 0 degrees Celsius. So when it's 32 degrees outside Fahrenheit, which is what we're used to, we would say it's 0 degrees Celsius. So the only one that you really have to do, and you're going to go ahead and show your work for that, right? The next one you're going to do is 50, right? Can you guys do those? All right, let's see if there's another part. The next thing that you want to do for B is use the table to make a graph of the relationship. So basically what you're going to do is you're going to treat these like x, y coordinates. So let's treat F like x and C like y. So I would plot negative 4, negative 20 on a graph, right? And now I'd plot 32, 0 on a graph. You probably want to borrow some graph paper because some of these are some pretty big numbers, right? Or make your graph so that could you go by 2s or even 5s and still be fairly accurate? You could probably make your graph a little bit smaller if you used a scale, okay? And you're going to graph those x, y points. Can you do that? Okay? But here's what you want to do, is that when you do that, you want to be really clear that this is F and this is C. Okay? Do you follow me? Because we're replacing those things. All right, and then finally, it wants you to find the slope. Well, we can find the slope of our line just using 2 points, right? What formula do I use to use 2 points to find slope? Okay, or y2 minus y1 over x2 minus x1. Okay, so I would do negative 20 minus 0 over negative 4 minus 32. Minus 32. Right? And that would give me my slope, right? I'm going to simplify that, but that's going to give me my slope. Is that enough information for you to kind of get all parts of that question down on? Okay, I'm going to hit stop right there. All right, you guys can use what time you have remaining.